So this is 2.2. What we're going to today, ladies and gentlemen, is, and in fact for several objectives here, we're going to be solving, okay? Today's focus is absolute values. We're going to solve absolute value equations, okay? And then in the next set of notes, we're going to change it to an inequality and see how that affects, what that affects. Okay, before we get to solving this, I just want to make sure we're good on how to solve equations and following order of operations. So doing a little review here of solving, because you definitely need to be able to solve just a straightforward equation before we add in the extra part of throwing in an absolute value. So number one here, would you solve for x? 2 times the quantity x plus 3 minus 7 equals 11. Okay, I want you to try it. Take about 20 seconds and try that. And then when you're done, I want you to share it with the person you're sitting next to. Share your answer. Okay, so go, solve it. Okay, I want you to share with your seat partner. And if you don't have one, share it with the people behind you or the people in front of you. All right. What did we get for an answer? Katie, what'd you get? 6? What'd you get? 6? Anybody else get 6? Katie, what'd you get? 6? Anybody else get 6? Anybody not get 6? Anybody get a different answer? Okay. Ricardo, what's the first step on solving this? You distributed, okay. So you got 2x plus 6 and minus 7 equals 11. Then what'd you do? Okay, so combine those and got 2x. Go ahead and tell me, minus 1. And then what? I got 2x equals, and then divide by 2. Okay, and that's how you get x equals 6. Did anybody do it differently? How'd you do it, Kate?
I added 7.
Okay.
Second step instead of doing 6 minus 7.
Oh, added 7 here?
Yeah.
So you still distributed?
Mm-hmm.
So you still, okay, so you went 2x plus 6, but then you added the 7 over and got 18 on the other side, and then subtracted 6?
Mm-hmm.
And got to the same point. Anybody do it by not distributing? Do you think you could get the same answer if you didn't distribute? Okay, so let's try that. What if I didn't distribute? What if the first step I did was add the 7 over? And I'd have 2 times x plus 3, and Ryan, what would I have if I added the 7 over? Add the 7 over here.
Oh, you would have
18. And then if instead of distributing, right now I divided by 2. You got to be careful here if you do it this way, but if I divided these would cancel. You'd have x plus 3 equals 9. Subtract the 3, and you get x equals 6. Same answer, okay? But, you know, distributing only added one step, so I'd say go ahead and distribute first. I'd probably stick with that method. What's that? Well, everything when you're solving, you kind of you do backwards, right? You undo, you do it backwards. We were careful here. You have to be careful here on the division. Okay. All right, let's try one more of these. Solve this one for me, please. 1 minus 2 times x minus 1 equals 9. Go ahead and solve that. And then go ahead and share with the person next to you. And do you guys agree on your answer? Do you get different answers? This one, there's an easy spot to make a mistake.
Oh, I need to see.
All right. Let's see. Emily, what'd you get for an answer?
Oh, x equals -3.
Okay, she got x equals -3. Anybody agree with that answer?
Oh, I agree.
I agree.
Anybody get a different answer?
No.
Okay. How'd you do it, Emily? What was the first step you did?
I distribute first
Okay, and what did you distribute?
the -2.
-2. And this is where you had to be careful, right? If you distribute the -2, you'd get -2x, but then here when you distribute it becomes plus +2. Yeah. Okay, and then what did you do next?
I subtracted. Oh wait, I combined +2 and 1.
Okay. And so did you write that as 3 minus 2x or -2x plus 3?
-2x plus 3 equals 9.
Okay. And then
And then I subtracted the 3.
subtracted 3, that would be the next step, right?
And
So
I
you'd
got
have,
6.
okay,
And then I
Divide by.
divided and got x equals 8.
very good. Okay.
I don't know. I just like to talk about it.
All right, you guys, so we're going to be doing some solving like that today. All right, so Roman numeral 2 here. Are we ready? The directions are this, okay? Shh. Solve the absolute value equations. And we're going to do it two different ways. We're going to do it graphically, and then B, we're going to do it algebraically or analytically. Okay? So first of all, graphically. So I'm going to write A here graphically. I want you to solve this graphically. And it'll be nice when you have it on your homework, you're going to have a nice grid to sketch it on. So we're going to freehand. You need to try to just be as accurate as you can, okay, when you're doing this. So we're going to accurately graph F and G on the same axis, okay? So here we go. Number 1, I want you to graph f of x equals the absolute value of x plus 1 and g of x equals 3. I'm going to graph those two things on the same axis, okay? So and all of these are going to be absolute values. You're going to have an absolute value and then something else. All right, so set up an x and a y axis. And we're going to take this absolute value graph and shift it which way 1 if it's inside the absolute values. Left 1, right? So normally what was right here has now been moved over here. That point is my vertex. And then the slope is the number in front. And what's understood to be there? A 1, right? So you're going to go up 1 over 1, up 1 over 1, up 1 over 1. I want you to keep going. Notice what g is. It's 3. Keep going until you hit a y value of 3, okay? And so then extend it that way, and then do the same thing in the other direction. Sketch that and then call it F. Okay, and then for the next graph we're going to do G. And it's g of x equals 3, which is a line. What kind of line? It's either vertical or it's horizontal. Which one is it? Horizontal, right? This is the same as y. Y equals 3 is horizontal. Okay, so I'm going to count up 1, 2, 3. This would be a horizontal line coming through here. Sketch that and label it G. Okay, so this is graphically. And what we're going to do right now is we're going to determine graphically, A, where does f of x equals g of x? And it's going to say it's that at x equals blank. Okay? So you're looking at where f is equal to g. What does that look like on the graph? Where do the two things equal? What does that mean graphically? Where they cross. Yeah, where they intersect. Okay, so right here, And right here is where those two functions equal each other. What's the x-coordinate? Okay, so what's the x-coordinate right here? If you graphed it, mine looks like it's at -4. Does that look like that's true for you guys too? -4, would you agree? Yeah? Okay, again, this is where we have to be a little bit accurate. So there, and mine's looking like it also hits it when x is 2. Is that where it looked right for you guys as well? Okay, so -4 and 2, that's what I think is going to be the solution now to, and now we're going to do it analytically, okay, or algebraically is actually what it's going to say. So for part B here, we're going to solve it algebraically. We'll write it out this first time, and then from here on out we'll just go A is graphically, B is algebraically, or analytically is another way. And what we're going to do is we're going to figure out where does f of x equal g of x. And we think we already know the answers to this. We think it's -4 and 2. Okay? F of x is the absolute value of x plus 1. G of x is 3, given to be 3. So I'm just going to set those two things equal to each other. Okay, here's the fun part. You ready for this? There are actually two things that could be inside those absolute values. Okay, I want you to ignore the x plus 1, so I'm going to cover it up. What could be in the place of where my finger is right now? What could be in the place of that to get an answer of 3? The absolute value of what equals 3? 3 and -3. Both of them, right? Isn't the absolute value of -3 also 3? So if what's inside the absolute value equals 3, that would be true. If what's inside equals -3, that would be true. So we're going to set up two cases. There's two things that could be true. What's inside is x plus 1. It could be 3, or it could be -3, and that would be true. Okay? So there's two cases, and you know what it's going to be every time you guys are going to get to this, and it's going to be the positive of that, and it's going to be the negative of that. Okay? And then solve this. Subtract 1 here, and you got x is 2. Subtract 1 here, and what do you get? X is -4. Okay, look at those answers, and look at what we found graphically. Same thing. Should be. Should be the same thing. Okay? It's because of this reasoning, absolute value could, what's inside could either be positive or negative. What comes out can't be positive. It has to be just positive, right? It can't be negative. But what's inside theoretically could be negative. And so that's why we set up both cases. All right, let's do one more of this kind, and then we're just going to do some algebraic stuff. Okay? So one more of this where we do the A and the B. Let's say in this case now f of x is 2 times the absolute value of x minus 1. And let's say g of x is 4. Okay, so let's first do graphically, show the two solutions, and then do it algebraically. All right, so set up an x and a y axis. Drop the x-axis way down, okay? Because we know we're going to be up at 4 based on what's given there. Okay. Which way is this absolute value graph going to be shifted? If it's -1 in parentheses? Right 1. Okay, so I'm going to shift it right 1. And then, so that's my vertex. And then I'm going to look at the slope, right? Got a slope of 2. So up 2 over 1 in both directions. And I want to go, you guys, until I can see I hit 4. So up 2 over 1 would be right there. Up 2 over 1. Actually, I think I'm already at 4, huh? And then go up 2 over 1 in the other direction. Up 2 over 1. I'm going to get there a little faster. So that's slope. So draw that, label it F. Okay, next thing then, graph G, which is the line y equals 4. So count up 1, 2, 3, 4 right here. It's a horizontal line. Label that G. Okay. And then on the worksheet it's going to say this, f of x equals g of x at x equals, and then a blank. Okay? So you'll look at the graph and you would have to know again that where this is true is where they intersect, where they cross. So right here and right here would be where they intersect. And this is saying, just give me the x-coordinate there. So what's the x-coordinate right here? -1, right? So that's one of my answers. And then what's the x-coordinate right here? Mine's looking like 3. Does yours look the same? Okay, so we'll say -1 and 3. And that's what I'm thinking is going to be the answer now when we do it analytically or algebraically. Okay, so that was part A. Part B now, algebraically. This is what we're finding. Okay, so I'm going to take f of x, which is 2 times the absolute value of x minus 1, and set it equal to 4. Okay, now this is different than the previous one because we now have a 2 in front. Okay, the very, very first thing you always want to do is get the absolute value. Anything inside's okay, but we don't want anything outside. So get that absolute value all by itself. We say isolate the absolute value. So I'm going to write that here. Isolate, that means get it all by itself, right? The absolute value. Okay, so the x minus 1 is okay, but that 2 is not. So how would I get rid of the 2? Divide. Okay, so I'm going to divide both sides by 2. This 2 can cancel. I still have the absolute value of x minus 1, but now it's going to equal 2 instead of 4. You'll get a completely different answer if you don't isolate it. Okay? Now, there's 2 things that could be inside that absolute value. There's 2 things that if I took the absolute value of them would give me a positive 2. What are they? What could be inside here? 2 and -2. Right? Okay, so I'm going to set up those 2 cases. It could be that x minus 1 is 2, or it could be that x minus 1 is -2. Either one of those would be right. Okay, and then solve this. Add the 1 to both sides. So if I added 1 here, I'd get 3. What is -2 plus 1? -1. And how does that compare to our 2 answers that we got before? Same thing. All right, now we're going to jump to just doing it algebraically and maybe kick it up a little bit, make it a little bit more difficult. Okay, so just algebraically now, not graphically. All right, number 3, f of x equals 1/2 times the absolute value of x minus 4, and g of x equals -1. Okay, so I'd like to start this algebraically, and then actually I'm going to show you a sketch of it really fast afterwards when you see what happens. Okay? So algebraically, to set f of x equal to g of x, I'm going to take 1/2 times the absolute value of x minus 4 and set it equal to -1. Okay? I need to get rid of that half first. How do I get rid of a half if it's being multiplied to something? Flip it over, right, and multiply. So the reciprocals, that we're saying, flip over 1/2 and you get 2, right? If I multiply both sides by 2, which is 2 over 1, these will cancel, right? 2 over 1. So we're left with the absolute value of x minus 4 equals -2. Okay, now, anytime you have an absolute value and a negative, be careful. Watch out. What would I need to have in here so that if I took the absolute value of it, I got an answer of -2? The absolute value of what is -2? If I took the absolute value of 2, does that give me -2? If I take the absolute value of -2, does that give me -2? Is there any way to ever take the absolute value and get a negative? There's no solution to this. We would write no solution because, can we do BC for because? An absolute value can't ever be negative, can't ever equal a negative. Okay, I want you to watch. I'm just going to sketch it really fast. Just watch this, okay? This would shift right 4. Whoops, went the wrong way. Right 4. From here, I would have gone up 1 over 2, up 1 over 2. Okay, it would look like this, right? Y equals -1 would be down here. When do they cross? Never. They never cross. Okay? So the key is absolute value with a negative. Just watch out. Watch out. This could be something going on there. Those aren't ever going to cross. So absolute value can't be a negative. Okay, I'd like to know for these, there's one other type of example I need to give you for this type of problem. 1, I totally got this. 4, I totally don't. I want to see where you're at, please. I see. Let's see, what do you got? 1, I totally got this. 4, I totally don't. Okay. So the last type of example then I want to give you, they're just going to add one little thing to it. Okay, so if you were at a 3, I think you'll get it from here. But it's going to say this. It's going to say solve algebraically. And then it's going to say graph the solutions on a number line. This is a different kind of graphing. So it's not saying graph the functions. It's going to tell you to graph the functions when, like the first couple examples we did. But this is saying just graph the solutions. This is really simple. Okay. The solving is going to be the most complicated part. The graphing's really easy. What number am I on, you guys? Number 4? Okay. So number 4, here's the problem. 1/6 absolute value of 4 minus 2x equals 3. Okay, so we're going to solve this just like we did the other, but now they're not telling us f and g, and we don't have to, graph those. All right, so first thing is isolate that absolute value. I need to get rid of 1/6. How do we do that? Multiply by 6, right? Multiply both sides by 6. Okay, so these cancel. This leaves just the absolute value of 4 minus 2x. And Jedrick, what's 3 times 6? 18. Okay, and then here's the thinking. There's 2 things that could be inside that absolute value. It either could be 18 in there or it could be negative 18 in there. That's what would give me that as an answer, positive 18, right? Okay, so I'm going to set up those 2 cases. So one, you just drop the absolute values just like it is. The other is you change the sign, okay, of that negative 18. And then I'm going to solve this. This was the kind of the solving we were practicing. So I'd first subtract 4 from both sides, right? And I'd get negative 2x equals 18 minus 4? 14. And then divide by negative 2. One of my answers is negative 7. Do you guys agree? All right. And then help me out with this one. Savannah, what's the first thing you'd do on this one? Okay, subtract 4. When I did that, I'd have negative 2x, and what would I have on this side? Okay, and then again, divide by negative 2, and what's x equal? 11. Okay, so those are our 2 solutions. Now, when they say graph these on a number line, it's really simple. The number line actually will be given for you like this, and it's going to indicate where 0 is. Okay, so you'll do it that way too. Just indicate where 0 is, then you're just going to approximate. You don't need to do tick marks. Just, okay, I'm going to say like right here is negative 7. Whoops, I meant to put a negative. Okay, and I'm going to put a dot there. Just put a big dot at negative 7. So 11 then should be a little bit further away. Just come over here on the right-hand side and put a big dot. That's it. That's all you have to do. This is a pre-step to the next where we're going to be doing inequalities. We're going to draw arrows. Just do the dot. Okay, pretty easy. All right, last one then. We're done with these notes. Same directions. 4 plus 3 times the absolute value of 3x plus 7 equals 1. All right, Alina, what would you do first if you were going to solve this? What's that? Yeah, I don't think I'd put anything inside the absolute values. I know that's when we did the example before. This would be a case where maybe we wouldn't want to distribute. What would you do first? Okay, yeah, we will. You know, I can't add the 4 and the 3 because this is 3 times. So you're right in that it's times. But get rid of the 4. How could I get rid of the 4? Subtract. Let's subtract the 4 from both sides. Yeah, I can't combine those guys. So 3 times the absolute value of 3x plus 7 equals negative 3. Then, to get rid of that 3, which is being multiplied, I would divide. Okay? And so I'd get the absolute value of 3x plus 7, whoops, equals -1. And this is where kind of bells and whistles, red flags should be going off. You got an absolute value, and on the other side you have a negative. Is it ever possible for me to take the absolute value of something and have it equal a negative? No. So what's the answer to this? No solution. So you just write no solution. We'll abbreviate it no SOL. And we'll say because an absolute value can't equal a negative. Math shorthand right there.